Okay, now that we sort of talked about how implicit differentiation works in general, let's outline the steps that we actually use to find the derivative for a full example. Because in the previous video we didn't really do any full examples, we just kind of showed how the process works. But now here's the full process. So step one is going to be differentiate both sides with respect to x. So WRT means with respect to. So differentiate both sides of the equation with respect to x. And then once you do that, you're going to have some stuff with dy dx in it and some stuff that doesn't have dy dx. So all the terms that have dy dx, get those all on one side and put everything else on the other side of the equation. All right? And then once you do that, step 3 is solve for dy dx. So usually what you'll do is you're going to factor dy dx out from one side of the equation, and then you'll just divide. So step 3 is usually pretty simple. Often the most complicated step would be step 1, and actually once you do step 1, step 2 is pretty straightforward. You just got to worry about keeping your minus signs correct and all that. But anyway, let's go ahead and do some examples here. So we'll do one example in this video and then some more in the next few videos. So we saw this one in the last video, y cubed minus sine of x equals 4 plus y. We want to find dy dx. So step 1 is differentiate both sides with respect to x. Okay, so here we're going to say d dx of the left side equals d dx of the right side. Okay, so some people like to put d dx of the whole equation. That's technically not really correct, but it's, I mean, people will know what you mean if you do that. But if you want to do something like that for your own work, just make sure it's okay with your instructor, whatever. But anyway, differentiate both sides with respect to x. So remember, this is all implicit differentiation. So technically speaking, we're implicitly differentiating. Okay, so let's go ahead and look at the left side here. So when we do that, use a different color. We have y cubed, and if we want to differentiate with respect to x, what's that going to be? Well, that's going to be 3y squared times dy dx from the chain rule, right? So remember, y is a function of x, and then we're taking that function of x and raising it to the third power. So it's one function inside of another function. So the chain rule says derivative of the big guy evaluated at the little guy multiplied by the derivative of the little guy. All right, and that's what's going on there. And then minus what? Sine of x is just sine of x. If we take a derivative with respect to x, we just have cosine of x. Okay? And then minus sign because of this minus sign up here. Alright, so now that's the left side. Now on the right side, what do we have? Equals d dx of 4 plus y. 4 is just a constant, so its derivative is 0. So we don't really even need to bother writing it, but I already did, so I guess we'll just leave it for now. Plus what? d dx of y. What's d dx of y? Well, it's just dy dx, right? That's all, just y primed, dy dx. Okay, so that's step 1. Okay, differentiate both sides with respect to x. That's step 1, we've done that. Step 2 is next. Zoom out just a little bit. Step 2 is get all dy dx terms on one side and everything else on the other side. So here, 3y squared dy dx. And then here's a dy dx. So we have two terms that have dy dx. So we want to put those on the same side. And here's minus cosine x, and here's a 0. The 0 we can just ignore, so let's maybe just go ahead and get rid of that. The cosine x has to be by itself on one side, and then dy dx terms all have to be on the other side. So let's go ahead and let's do this. Let's add cosine x to both sides, and then we'll subtract this dy dx from both sides. So first we're going to have 3y squared dy dx equals cosine x plus dy dx. Alright, and now subtract dy dx from both sides. 3y squared dy dx minus dy dx equals cosine of x. Okay, do we really need to split it up into two steps like that? No, not really, but I just want to show you in detail what's happening here. So now 3y squared dy dx minus dy dx equals cosine of x. So that's step 2. Step 2 is done now, because everything with dy dx is on one side, everything else is on the other. Now step 3 is solve for dy dx. Okay, and like I said, I didn't write it down, but like I said, we're usually going to have to factor, and that's actually what we're going to do here, because this is 3y squared minus 1 times dy dx is pretty much is exactly what that means. So we can factor a dy dx out, and we're going to have dy dx times the quantity 3y squared minus 1 equals still the cosine of x on that side. Okay, so that's what's going on there. And now we can just divide both sides by the quantity 3y squared minus 1, and then that'll be our answer. So dy dx equals cosine of x divided by 3y squared minus 1. And that's our answer there. So that's dy dx. So notice that the derivative has both x and y in it, and that's okay. You know, all the derivatives we've done up till now, they didn't have y in them, right? But it's okay in this case because remember, this is implicit differentiation. We're dealing with implicit functions here. So we should kind of expect to have a y here somewhere in the derivative, okay? Because otherwise, you know, if there were no y's over here, we'd be able to express y explicitly as a function of x, probably, unless we have a really simple example. But in any case, so this is perfectly acceptable here to have x's and y's, because y is implicitly a function of x. So that's example 1 with implicit differentiation, and there's more to come in the later videos.